Hi and welcome to part number 4 of this tutorial of how to build a ReAmiga 3000. Last time we left when I actually got the board to work as I hoped it would after a small mishap with Dirty Gary. But actually that was not the entirely true thing, as I never connected the video output. So we do that again and let's see what's happened. You can see in the green flashing there, that's diagram. And yeah, doesn't look good at all, right? Nah, it looks crap actually. And yeah, I was discussing this with Peter Mulholland and he suggested me to check out U257 and 258, as they handles how the chipset talk to the chipman. And I did something that I really don't like, that way of testing, but why it works. So I put similar chip 74F245 above, on top of U257. Let's do that and power on and see what happens. And yeah, something there. For some reason my capture card doesn't really like the non-interlacing mode. Anyway, I got a perfect picture, etc. So I think I have to replace that chip. And this kind of thing works only. Oh, do not touch it. Interesting. It started playing on me. Only if it doesn't last. If it's internal short, then it will not work. So it's not always a granted way of testing a chip, but yeah, why not? So that chip is bad. One of few times actually I've noticed a bad chip when doing a move. Sometimes it happens, actually, yeah. So put on this, remember where it is, and use my desoldering gun. Okay, interesting. I think I know why this chip was bad, because it actually cracked. Interesting. It actually cracked. Well, anyway, that's maybe the reason. It was a bad chip of some way. Okay, interesting. Never happened to me before. You ever have a chip crack? Anyway, now it's removed. I have one pin, the pin that I tapped. And let's take a non-cracked. Slightly bent because I put in there. Okay, that chip is replaced. Let's see what happens. Put in some serial port as well, so because why not? And come on. Yay. Okay, fixed. Back to business. Okay, that's done. Now for the next part, that's actually to get some kind of control. So let's do the mouse and serial input. If you noticed that this was on board, the board when I removed the other chip, it was just me for testing for if it fits, and yeah. So now I've actually put it in here and solder it in. So we have mouse and gameports, so we can actually control the Avron. And I'm lazy, having the metal shield already in place. Okay, that's done, but the ports will still not work because you will need to populate U401 with 74F 157, if I'm correct. Yes. This handles sounds data to Agnes, I think, has actually a serial data. And to have serial input, you need to populate U305 with the 1489. Let's do that as well. And well, if you haven't put it on, I think it's time for the serial port for real. Okay, that's it. So let's try it. This time not with the IDC, but with the serial port. Audio. And putting a mouse, some power. And we can test it now by powering on there, and you can see serial output and display. Push the red right mouse button there to not have to wait and still have serial output. And bring up my PC keyboard here, connected to my PC. Activate putty, and yes, I can now have serial output or input, and mouse is also working. So let's do an audio test. Yay! And that module is actually designed so if there are any audio issues, it will be stopped. And well, we can do another test. Like, let's do the CIA tests or RAQ test first. And they pass. Yay. We can do the CIA test, the old version. And it fails. Why? Because we haven't populated that one yet. You can do the new test as well. That should work on both PAL and NTSC machines, with a small exception that will not be noticed here. The timer, the testing on CIAB, the TOD will actually always fail. I need to fix that number. But now it's failing because it's simply just not there. So, okay, that's it. Can do another fast. We can do like this as well. We can put in. We can do port test and do mouse port. And I have this test from the sys test joystick test angle from Martin, I think. Anyway, what I do is I put it in here, and it will automatically move the joystick and press all buttons for me, as I don't have any joystick actually. And we can test the other port. Works fine. And serial port we don't actually have to, yeah, we can test it as well. I have a small tutorial here as well. Push down both buttons. Of course, stupid, you have to attach the mouse. And that flickering you can see there is actually waiting for me to release the port. And serial port, do it like this, and it will fail now because it will. You can see the putting out crap on the serial port. I put in the serial port dongle, SCSI compatible. Put it in here, and oh, do not do that. And you can test the serial port dongle as well. It's best to do it actually with it attached with the, and power on. Like that, and notice that I now got the deinterlacing working. Port test, serial port, press, and it will say bad on RTS, etc. And that's because that CA is not connected. So yeah. So I think maybe that will be the next thing to do, is to add some other stuff so the diagram will pass more tests. Also I can do like this first. On the adapter you can see I have two LEDs, and bind all cables there, and that's actually showing that we have 5 and 12 volt on the port, and you can see that the 12 volt takes much longer to go out. Yes, so time to do the other CA, and I have to get the socket for it. Okay, put it here. Okay, we have done that. So the next CIA in place, in the dongle, in RGB, mouse, power. Okay, test it here and power on. Yep, and as you can see, it's, startup is much faster as I have the loopback adapter installed, and you can see zero loop, so it doesn't output anything to serial port. So we can do a port test first here, serial port, and you can see now that it's testing okay, and yeah, everything there. Let's do CIA test. No memory test. CIA test and test CIAs. Yep, working. And the experimental one. And yes, okay on PAL because this is a PAL machine, so NTS will say fast. And due to bug that I haven't fixed yet, CIB TOD will fail. And if I had this jumper wrong to tick, and as here I'm using a normal ATX power supply, and we can do a test. We do the experimental one, and you will find that the CIA TOD will fail because I'm not using 3000 TSU that supplies the tick signal. Anyway, that's it. Now it's time to populate those 3 chips, and by doing that we will actually get floppy working. Now actually sadly I don't have any floppy drives, so I cannot test it, but it should work. Maybe for the last program part of this one I test one. So at 355 we have 74 LSO8, and 351 we have a 74 LS74, and last here at 353 we have 74 LS00. They handle both floppy motor and all that. Yes. And well, floppy motor more like, because it takes signals, it's to handle extra DF1 etc. from me. But anyway, there. Remove that one because I'm not needing that dongle anymore. Time for the IDC connector floppy, and I'm using the shredded ones because they look better, feels better, just it's better. Don't get cheap when you're doing this because this is an expensive build anyway. Okay, done that. I think it's time for the terror port and external SCSI. The there are an IDC connector here for 25 pin that can use an IDC cable, so you can have a new connector here that goes this dual 25 pin female. I haven't seen. This is so far untested, so if anyone tested this and is successful or not, please tell me. Anyway, I'm putting this one from the old donor board. Okay, parallel port tested and or soldered, and SCSI port, but I will now test the parallel port one and take another dongle, put it in here. Power on, and without power cable, no, power on, and you can see this small light there, and diagram start. Port test, parallel port, and it runs okay. Good. We're done with that. So fast working. Now it's fast. Now we should have working floppy and so on. So next part should be actually to get SCSI working, and for that we need to have place the IDC connector, we need to place a SCSI chip and the DMAC. And low CSI prepared, I must find those components and sockets. Okay, so simple. Put in the SCSI chip or a socket for the SCSI chip. And then the DMAC. And finally, the IDC connector for the SCSI. Folded here as well. Note the small marking for one at the board also. And I have apparently something in the hole there, looks perfect. And I just heat up here. Yep. That's it. Apparently some solder in the hole. Yep, good. Okay, that's in. Put in the DMAC or DMA controller. The SCSI chip. I see this one is a 0004 prototype. When I will send this to the owner, he will get an upgrade to the newer version of the SCSI chip instead. Somewhat fixes. Okay, we are soon actually populated here. We need some more stuff. We need actually keyboard connector. Here is a standard DIN connector, and we can also have the PS2 type, the Amiga 4000. It's not PC. You cannot put in the PC keyboard without an adapter, but if you're using a Lyra adapter, etc., then you will need an adapter from big DIN to small DIN, or just put this in directly. It will fit. I haven't really tested it, but it should work. Then it will look like that, or just a standard ordinary 3000 DIN connector. The owner wanted old style. He gets old style. And always hold the component when soldering in. Done with this, and be generous when it's soldering all connectors. Oh, alarm. Be generous when you solder all connectors, because there are people jacking it, etc. So I'm more sturdy in it. Okay, we have some few things left for this build today, and now it's time to get Zorro working, and for that we need the buster. And as always, not prepared, so I need to get a socket, etc. On time to put in the buster socket. And put in the buster chip. This is a version 9 and 11 is the best. Remember that 11 is not compatible with the 16 MHz 3000. Why you ever wanted to have 16 MHz, when you're already building it? Yeah. And okay, now it's time to put in the Zorro connector. But before that, see if I am prepared. But as it here is quite close to 2 caps, or at least to that one here, I will populate them so it's easier to have it done now than with the connector in place. Okay, it's done. Now time for the Zorro connector. So this is removed from the old machine. I know that this one is perfectly available new. The other one I haven't found. If anyone have a part number for working part here, please do tell me. And We need this because to boot Kickstart Workbench we need a daughter board in the 3000, not for diagram as you can see, but for Workbench we need it. Actually do both at the same time. Make sure that it's firmly directly, not tilted or anything. The one solid point there, push it up, make sure it's really there. Another point here. Same here with this one. Make sure it's aligned. Now I notice that I actually have some resistor pack here that I haven't soldered. Done. Okay, now we have this done, and actually I will call it a day now. Next time we will add the RTC and the adjustments for that one. We will add the flick fixer and adjustment for that one. We'll add the rest of the caps and LED connector here with battery, and then we will hopefully put it up and have a fully working machine. So that's it for today. I hope you enjoyed it. And of course a light small add-on. I forgot to put on the floppy connector. I will solder it in. No need to film that one. That will be soldered on as well. That's it.